Hey everybody, it's Mr. Roy. Let's get into a unit review. We're looking to wrap up our quadratics unit, or our introduction to quadratics. We do have a bit more quadratic stuff to do, but this is going to wrap up our first unit in quadratics. And so let's go over some of the key concepts that we learned in this unit. First one, determine if the following relations represent linear, quadratic, or other relations. So really we're looking for the degree of these things. We know that a second degree quadratic, that's something that's got its biggest term as a squared term. That would be a quadratic. Things that's got a degree of 1 is linear, and higher than a degree of 2, like a degree of 3, 4, 5, we get into funkier looking relations. Let's have a look at our first one. This is our table of values. So with the table of values, we're going to be looking for first and second differences. So we're looking to see how these change as we go from one y value to the next. So I would first start by saying, okay, we're going to take where we end up, minus 5, and we're going to subtract 9 from it. So negative 5 minus negative 9, subtracting a negative is like adding, that's 4. And really you could look at it by saying, we go from negative 9 to negative 5, that's going up by 4. Same deal, negative 5 to negative 1, that's going up by 4. Negative 1 to 3, that's going up by 4. 3 to 7, that's going up by 4. So this has first differences that are the same. The first differences are the same. So what does that mean? That means it's linear. If the first differences are the same, it's linear. If the second differences are the same, that would tell us that it's quadratic. Let's have a look at our next one over here. For b, we have 2x times x plus 2 times x minus 1. Now I could multiply this whole thing out, but I don't actually have to. I know that when I multiply the whole thing out, I'm going to end up with one term that is x cubed. Right? Because we've got an x here and an x here and an x here. When I multiply all that out, I'm going to end up with an x cubed term. So is it linear or quadratic? Well, it's neither. It's neither because it's got an x cubed term in it. It's a third degree relation. Okay, so we could do it with a table of values. We could do it with an equation. Let's move on to number 2. For the parabola shown, determine the following properties: the vertex, the optimal value, the max-min, direction of opening, second differences, zeros, and axis of symmetry. In your assignment, you'll have done similar things with this. So here we go. With our vertex, we can just spot it. It's right here. By the way, you should pause the video, see how much of this you can do, and then come back and check out my answers. So that's at a point of 1, 4 on our grid. So our vertex is at 1, 4. Our optimal value, that's our y-coordinate of our vertex. In this case, it's a 4. So we're going to say y equals 4 is our optimal value. If we're doing like an optimal problem, then that will be useful for us. Is it a max or a min? Well, it goes up, 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 up to a maximum and then comes back down. So this is going to be a maximum. There is no minimum. It keeps going down, 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 down forever. Direction of opening is down. It's a frowny face. It's got a direction of opening that's down. The second differences. Now, from this, I don't have to write what the second differences are. I need to know if they're positive or negative. It opens down, so I know my second differences must be negative. So I got negative second differences because it opens down. What are my zeros? Now, I could write these as x equals whatever because they are x-intercepts. Zeros mean x-intercepts. But in this case, I'm just going to write them as points, although I would accept it as x equals negative 2 and x equals 4. But writing them as points, it's negative 2, 0, that's over here, and 4, 0, that's over here. Those are my zeros. What's my axis of symmetry? Well, that's my line that goes through the middle of the quadratic, and it hits my x-axis at 1, so x equals 1 is the equation of my axis of symmetry. Okay, so I've labeled the whole quadratic. You'll recognize something very similar to that from your assignment. Let's move on to number 3. For the following relations, determine the zeros, the equation of the axis of symmetry, the coordinates of the vertex, the y-intercept, the size compared to normal, is it stretched or squished, and the direction of opening, up or down. Okay, so let's have a look. Well, that's a lot of stuff to get through. So let's have a look at our first one. Okay, for A, we have to find the zeros. So to find the zeros, I just have to look in the brackets, and I'm going to take the opposite sign, right here and right here. So my zeros are going to be x is equal to 3, or x is equal to negative 7. Those are my x-intercepts for my zeros. Again, you could write it as points. That would be fine too. For B, we're looking at the equation of the axis of symmetry. The axis of symmetry is halfway in between our zeros. So we'll say the equation of the axis of symmetry is going to be 3 plus negative 7. It's the same as 3 minus 7 divided by 2. That's going to give us the average. So that's negative 4 over 2. So that's negative 2. So the equation of our axis of symmetry is x equals negative 2. Now we want to do our coordinates of our vertex. Well, I already know one of them. It's negative 2 because that was our axis of symmetry. So I already know one of the coordinates. And if I know an x, I can sub it into my equation and I can always get a y. So let's use our equation to find that. So we're going to say y equals negative 2. And everywhere there was an x, I'm going to put in a negative 2 in its place. So everywhere there was an x in my equation, a negative 2 goes in its place. What does this work out to? We've got negative 5 in this bracket, and we have 5 in this bracket. So negative 2 times negative 5 times 5, that's positive 50. So our vertex is at negative 2, 50. Those are the coordinates of our vertex. Okay, D was the y-intercept. The y-intercept. Now we know our y-intercept occurs when x equals 0, right? So we'll say, okay, when x is 0, what's our y going to be? Well, let's use our equation. Let's put in a 0 everywhere we see an x. Well, that's going to be negative 2 times negative 3 times 7. Work all that out, that's going to be positive 42. So what's our y-intercept? It's at 42. Rolling along here, we're moving quick. We got E. E was asking us what is the size compared to normal? So is it stretched or is it squished? It's got an A value in front. Let's go back to my equation up here. Let's get out my highlighter. It's got an A value in front right there of negative 2. So anything a 1 would mean it's normal. A 2, 3, 4, 5, or negative 2, negative 3, negative 4, negative 5 would mean it's stretched. So it's not a decimal or a fraction. This is going to be stretched. So I'll say it's stretched. In the brackets, I'm going to put narrower. So it appears narrower when we graph it. And we're also going to put in brackets A is greater than 1. I know it's a negative number in terms of A, but we're really just looking at that like number itself. Is it greater than 1 or is it in between 0 and 1? Okay, now F was, does it open up or down? It opens down. And how do I know that? It's got a negative value at the front. So that means it's going to open down. Okay, so I've gone through all those. Let's do it one more time. This would probably be a good idea to pause and see how you do. This next one is a little tricky though. It's got its own kind of tricks, but before you jump in, give a pause and see how much of it you can come up with. Okay, let's jump in with A. A was, what are my zeros? So I can tell one right here, it's going to be negative 12. But what about this one right here? Well, really what that is x plus 0, right? We don't write the 0, so we just end up with an x. But really what that is x plus 0. So my zeros are going to be 0 and negative 12. So that can be a little tricky. You can think, oh, there should only be one 0. No, there's still 2, but one of them just happens to go through the origin, happens to go through 0. Okay, B was my axis of symmetry. Let's take the average of these two. My axis of symmetry is going to be 0 plus negative 12 divided by 2. That's negative 6 divided by 2, which is negative 3. So my axis of symmetry is at negative 3. Oh, sorry, no, I already did the division. That's a mistake. Good thing we caught that. Caught it early. That's going to be negative 12 over 2, which is negative 6. I think I did that division in my head before it was time to do it. Okay, so x equals negative 6, that's our axis of symmetry. So our next one is the coordinates of the vertex. Well, we already know one of them. It's negative 6. It's our axis of symmetry. So if we know our x value, we can just plug into our equation and get our y value. So 1/4 times negative 6 times negative 6 plus 12. Okay, let's figure this out. So that's going to be 1/4 times negative 6 times positive 6. Really, multiplying it by 1/4 is the same as dividing it by 4. So we end up with negative 36 divided by 4, that's negative 9. So our vertex is at negative 6, negative 9. We can always find our y-coordinate of our vertex if we know our x-coordinate of our vertex. And we can find our x-coordinate of our vertex if we know our zeros. So as soon as we know those zeros, we know right away we can get to the vertex. That's a really important skill set to practice. Pick out the zeros, find the axis of symmetry, use that by plugging it back into the equation to get your y-coordinate of your vertex. So as soon as you have 2 zeros, you know you can get to the vertex right away in any problem. Okay, what was D? D was our y-intercept. So we'll have to set x equal to 0. When we set x equal to 0, what does our equation work out to? Well, we got 1/4 times 0 times 0 plus 12. Now, I don't even have to work this out because these are 3 terms. One of them happens to be 0. You multiply all that out, you get 0. So what's our y-intercept? Our y-intercept is 0. That's at the origin. Okay, and E. Is it wider or narrower? Is it stretched or squished? Well, in this case, it's squished, which means it's wider. If I graphed it in Desmos, I'd be able to see that easily, but how can I tell? Well, it's got a 1/4 out front. It's got a number that's between 0 and 1, so that means it's going to be squished. It's going to be wider, appear wider when we graph it. Does it open up or down? Well, that value is positive, so it's going to open up because that value in front is positive. Okay, we're knocking these out of the park. Let's keep on rolling. Here we go, number 4. The x-intercepts of a quadratic relation are 2 and 6. Ooh, okay, we know the x-intercepts, the zeros. That means we already know if we needed to, we could get to the vertex if we had an equation. Now in this case we don't have an equation, so this question is going to go a slightly different direction here. So the x-intercepts of a quadratic are 2 and 6. The second differences are negative. Which direction will the parabola open? Is the optimum value positive or negative? Is the y-intercept positive or negative? So we're really going to benefit from just drawing a quick little sketch for this one. Okay, so let's do that here. I'm going to draw my grid, and I notice my x-intercepts are 2, let's say that's right there, and 6, let's say that's right there. So 2 and 6. It says the second differences are negative, meaning it opens downward. So that means if it opens downward, it's got to be something like this shape. I can't be sure of the exact shape. It might be taller or shorter or whatever, but it's going to be opening down, so it's going to be that shape. So which direction will the parabola open? It's got to open down because the second differences are negative. What's the optimum value? That's our y-coordinate of our vertex. Is it positive or negative? It's got to be positive because we know that optimal value is above the x-axis because it's opening down. And is the y-intercept positive or negative? Well, we know the y-intercept is going to hit it somewhere down here. I'm not sure where, so the y-intercept has got to be negative. So can we think about what we know, draw a little sketch of what it might look like, and then interpret that information? Sure, we can. Okay, let's work on our expanding a little bit. because we can go from factored form to standard form. Standard form is a pretty useful one. It's going to tell us the y-intercept nice and easily. We also have an equation in standard form that we can use to find the vertex. It's very handy. Okay, so here we go. We're going to expand. We're going to multiply through the brackets. So we'll go first terms multiplied, outside terms multiplied, inside terms multiplied, last terms multiplied, FOIL. X times x is x squared. X times negative 2 is negative 2x. 3 times x is 3x. And 3 times negative 2 is negative 6. We're going to collect our like terms. I see them. They're x's. Those are the only like terms. We cannot combine them with our x squared. Negative 2x's, add 3 more. That's going to leave us with 1x. Okay, let's have a look at our next one. This has a squared term, meaning we're going to have to actually write it out twice. We should always write it out twice just to make sure we're not making any mistakes here. Okay, now let's multiply through the brackets. Let's go first, outside, inside, last. Multiply everything in the first bracket by everything in the second bracket. 2x times 2x. Well, 2 times 2 is 4. X times x is x squared. 2x times negative 5, that's negative 10x. Negative 5 times 2x, 5 times 2 is 10, but it's a negative 5. And negative 5 times negative 5 is positive 25. Collect our like terms. These ones are really good ones to pause, right? So you should be pausing the video, try them, see how far you can get, and then get a little help if you need it. Okay, my third one. I'm going to leave the 3 out front and just deal with that later, because it's going to be easier to deal with that later. So I'm going to multiply first, outside, inside, last, and then I'll deal with that 3. So that 3 is going to stay out front. Let's put some brackets in there so we don't mix anything up. Now let's do our multiplying. 5x times 2x, that's going to be 10x squared. 5x times 3, that's going to be 15x. Negative 1 times 2x, that's negative 2x. Negative 1 times 3 is 3. Now we can multiply this 3 through and multiply it by everything inside the brackets. So distributive property through the brackets. 3 times 10x, that'll be 30x squared. I should have combined my like terms first. Sorry about that. So I'm just going to kind of go over that step. 15x minus 2x is going to be 13x. So 13x times 3 is 39x. And 3 times 3 is 9. Oh, and this should be negative. Sorry. Get out my little eraser here and fix that up. You're probably screaming at your computer screen right now. Mr. Roy, it should be a negative. Well, you'd be right. It should be a negative. I promise. That's my first math mistake ever. Ha ha ha. Okay, so negative 9. There we go. Okay, we got that one all worked out. Now let's get to a couple that are a little trickier. Okay, so this one I'm going to first say distributive property. I can multiply through here. And this one I can multiply the 2 brackets, but I'm going to have to separate them out. So let's first just write it the whole way we want it to be seen. 4x minus 1 times 4x minus 1. Okay, let's multiply the 2x through the brackets. 2 times x is 2x. 2 times 1 is 2. Now this is where it gets tricky. We're subtracting everything that's in these 2 brackets. So I'm going to leave the minus there. I'm going to put some brackets here and do all my work. And then remember that it's actually a negative 1 out front. And I got to multiply that negative 1 through the brackets. So this is tricky, no doubt. 4x times 4x is 16x squared. 4x times negative 1 is negative 4x. Negative 1 times 4x is negative 4x. Negative 1 times negative 1 is positive 1. Okay, now I actually have a hidden 1 right here, right? It's really a negative 1. That's what that negative out front means. So I got to multiply that negative 1 through the brackets. That's going to change the sign of everything in the brackets. So I don't actually have to think it through. I just need to change the sign. Because you multiply anything by negative 1, it just changes the sign. This was negative 4x. Negative 4x, that would have been negative 8x when I combine them together. So it's going to become positive 8x and negative 1. Okay, there we go. Now that I've worked all that out, are there any other like terms I can put together? The 2x and the 8x, I can put those together. And let's write our x squared term first. So we got 16x squared. Let's combine our 8x and our 2x to be 10x. And let's combine our regular numbers. 2 and negative 1 will just equal 1. So negative 16x squared plus 10x plus 1. Whew, that's a tricky one. Okay, last one. This is where FOIL doesn't really work anymore, right? Because the first, outside, inside, last, well, this one has 3 terms in it, so that's not going to really work for us. So we just need to remember, multiply everything in the first set of brackets by everything in the second set of brackets. So we'll multiply that x by everything, and we'll multiply the 1 by everything. Cool, let's do it. X times 2x squared. Well, the 2 stays, and now we've got 3 x's being multiplied together. So that should be 2x cubed. Okay, x times negative 5x. That's going to be negative 5x squared. X times negative 1, that's negative x. 1 times 2x squared, that's 2x squared. 1 times negative 5x is negative 5x. 1 times negative 1 is negative 1. Cool. Let's combine our like terms. Well, we only got one term that's a cubed, 2x cubed, so we can put that out front on its own. Let's combine our x squared terms. We got one there and one there. So negative 5x squared plus 2x squared, that's going to leave us with negative 3x squared. Let's have a look for our x's. We got a negative x there and a negative 5x there. Combine those together, negative 6x. And we only have one regular number, it's that minus 1, so we have no like terms to add it to. There we go, we did it. Woo! Tough stuff. I feel like a math ninja. Okay, let's keep going. Next one, what was that, number 5? Now we're on to number 6. A parabola has x-intercepts of negative 4 and 6, and a y-intercept of negative 6. Write its equation in factored and standard forms. What is the vertex of the parabola? Is the optimal value a maximum or a minimum? Okay, a little bit tricky. Here we go. First of all, I want to recognize for A, if I can get the equation in factored form, then I can get it to standard form just by multiplying through the brackets. So I think I can do that, but here's the catch. With factored form, I don't know the whole equation. I'll start by writing what I can. So here's A. I can write it like this. I know I've got x plus 4, because that's one of the zeros, was negative 4, so I write x plus 4 in my equation. And I write x minus 6 in my equation, because those are the opposite signs of the zeros. But here's the catch. There might be some number out front, and I don't know what that number is. Well, here's the nice thing. I do know a point. What's the point? It's the y-intercept. Well, we know the y-intercept is when x is 0, y is negative 6. So we do actually have the x value for that point as well, even though it may not seem like it. We know it because it's 0, negative 6. That's what a y-intercept is. The x value is always 0 there. So we can take that point and sub it in to find our a value. Let's put the negative 6 where y was, and let's put the 0 where the x's are. This point that we have is going to tell us our a value. Okay, so now we'll divide both sides by negative 24, and we end up getting a is 0.25, and it's positive. So a quarter. But I kind of like writing as a decimal in this just because it'll make it a little neater and easier to write. So y is 0.25, x plus 4, x minus 6. There we go. Not my best 6 ever. Okay, cool. So now that we've got this in this form, we can keep going with a. So I'll keep my pen color the same. I'm going to go up here. And we can actually just multiply through the brackets to turn this into standard form. So let's do that. I'm going to leave my 0.25 out front. I'm going to multiply through the brackets. X times x is x squared. X times negative 6 is negative 6x. 4 times x is 4x. And 4 times negative 6 is negative 24. Now we got to multiply through the brackets by 0.25. But first let's combine our like terms just to make it a little easier. So we got x squared, we've got negative 2x, negative 24. Now let's multiply by a quarter through the bracket. So we end up with 0.25 x squared minus negative 2 times a quarter is going to be a half, so 0.5x minus 6. So that's our equation in standard form. So we've got our equation in factored form and in standard form. Let's put boxes around the important ones. Because if we're doing this on a unit test, we want to make it really easy for our teacher, Mr. Roy, to find it and know that we got to a final answer. Okay, what's the vertex of this parabola? What's the vertex? I'm going to change colors to blue. I'll put it right here. To get the vertex, we say, okay, I've got an equation that's going to help me find that. And so here's my equation when it's in standard form, right? I could, knowing the zeros, I could find the average between them. And that would be my x-coordinate of my vertex. And then I could sub that into my equation to get my y-coordinate. But let's do it the other way. Okay? Let's do it the other way. Let's do it by going and using our formula for standard form. So our formula for standard form says negative b over 2 times a. So here we go. What's our a, b, and c? That's our a right here. That's our b right there, and that's our c right there. Okay? So we'll say, all right, x is going to be equal to negative b over 2a, so negative 0.5. Well, it's the negative of negative 0.5, so that's 0.5. And 2 times a is going to be 2 times 0.25. All right, so what does that work out to? That's going to work out to 1, because a half, 2 times a quarter is a half, so that's going to work out to 1. So that's the x-coordinate of our vertex, right? That's our axis of symmetry, which is also the x-coordinate of our vertex. So let's go to our next step. Let's sub that into our equation in order to get our y-coordinate. So we'll go y equals 0.25 times 1 squared minus 0.5 times 1 minus 6. What does that work out to? It works out to negative 6 1/4. So that means our vertex is at, oh, I don't need an equals sign. My vertex is at 1 and negative 6 1/4. Awesome. Now C is going to actually be really quick, because C just asks us, is the optimal value a maximum or minimum? We know from our a value in front of our equation, right here and right here, that it's a positive value. So what does a positive value mean? Positive value means it's pointing up. It's opening up, so it's a minimum. So I'm going to say A is positive. So opens up. Therefore, it's a minimum. Cool. Okay, we're rolling along. We're getting near the end. The end is in sight. Hooray! Let's do a couple of the trickier questions here. Let's try one of these ones. You can probably expect there's going to be something like this on the test. So this is a good thing to study, these optimal value ones. And they're not going to be very different from the ones we did in class. Okay? So you should expect, if you're studying the ones we did in class, you're going to see ones that are really similar, that have all the similar kinds of components and just slightly different numbers, right? So if you're studying these, you should be in good shape. A retailer sells sunglasses for 15 bucks and has 50 customers a day. From market research, he discovers that every dollar increase of the price of sunglasses, he'll lose 2 customers a day. What price should he be charged to maximize revenue? How much revenue is made per day? So we need to actually make a quadratic. We need to make it. And then we need to analyze it and find the vertex. Okay? So how do we make the quadratic? Well, here's what the quadratic is going to be. We're interested in the revenue, how much money we're going to make, right? So a revenue equation. And what is your revenue? Well, it's the price for a pair of sunglasses times the number sold. That's how much money you make from selling those sunglasses. So, okay, how does that work out? Well, the price for a pair of sunglasses is 15 bucks. And the number sold is 50. But we're thinking maybe we'll up the price by X. I'm going to call it 1X just to be really clear. So that would be a $1 increase. For every $1 increase, though, we're going to lose 2 people. So we're going to lose 2 sales. Okay, so the question is, can I get the vertex from here? And the answer is, yeah, sure I can. Why not? Though, what's the best way to find the vertex? This one, we can't easily look at it and find the zeros. I can find one of them, it's negative 15, but the other one, this has an x value with a 2 in front of it. So I can't just say, positive 50 or something like that. I'm actually going to have to put this in standard form and then use my equation. So let's do that. Let's put this in standard form. Here we go. We're going to multiply everything out. So first thing we're going to do is we're going to go 15 times 50. Well, that's 750. Then we'll go 15 times negative 2x. That's negative 30x. Then we'll go x times 50. That's 50x. And then we'll go x times negative 2. That's negative 2x squared. Let's rewrite this. So we've got our x squared term first. Our x term second, negative 30x plus 50x. That's going to be plus 20x. And we combine those like terms, plus 750. 750. So that's our equation. We could just graph it on Desmos, but we're practicing our skills here, and on test day you're not going to have Desmos in front of you. We do need to show that we have these core skills and we really understand where we get this stuff from. So now let's find our axis of symmetry using our equation. So we're going to go x is negative b, so that's negative 20. Let me put those labels on there. We got our A is there, our B is there, and our C is there. So negative 20, because it's negative B, divided by 2 over A, 2 over negative 2. Well, that's going to work out nicely. So we have negative 20 over 4. So we're going to have an axis of symmetry of x equals 5. So that's our x coordinate of our vertex, x equals 5. Okay, cool. So now we can actually figure out, now that we know 5, that means how many price increases do we do? We do 5 $1 increases, 5 $1 increases. But we're going to lose some people. We're going to lose, for every $1 increase, we lose 2 people. So $5 increase means we're going to lose 5 times 2, we're going to lose 10 people buying sunglasses. So we need to figure out what price should be charged to maximize revenue. Reminder, our price over in our equation at the beginning there is 15 plus 1x, right? So 15 plus x, we found out that x at our maximum is 5. So our price is going to be $20 per pair of sunglasses. And we want to know how much revenue we're going to make from that. So let's figure out the number, let's figure out the whole revenue. So our revenue is going to be 15 plus 5 times 50 minus 2 times 5. So that'll end up being 40 in that bracket. So we go, okay, that's going to be 20 times 40 What's that work out to? That's 800. So maximum amount of money we can make from this is 800 bucks. So our coordinates of our vertex are 5 and 800. Tricky, but it's going to follow the same, basically the same pattern each time. So practice and study, and you'll see when you get to one of these, it's going to look pretty similar. Okay, let's do our final one here. For y equals negative 2x squared plus 6x minus 3, determine the y-intercept, the direction of opening, the axis of symmetry, and the vertex. These we can do pretty quick. The y-intercept is easy peasy to find because we know we'd have to put in x equals 0 to find the y-intercept. Well, if we put in x equals 0, our first two terms are gone. And all we're left with is negative 3. It's really easy to see the y-intercept when we have things in standard form. The direction of opening is going to be down because our a value that's in front of the x squared, which is right here, is negative 2. It's a negative number, so that means it's going to be opening down like a frowny face. Our axis of symmetry. Okay, we can find the axis of symmetry using our equation, negative b over 2a. Well, negative b over 2a, b is 6, so negative 6 over 2 times a is negative 2. What's that work out to? Negative 6 divided by negative 4, that's 1.5, and it's positive. Finally, our vertex. Well, we've got our axis of symmetry from our equation there, so our vertex, we just need to use our equation and sub in. When we work that out, that's just calculator work, that's 1.5. So what's our vertex? Our vertex is at 1.5 and 1.5. How about that? Okay, so this covers the main ideas that we've covered in this unit. If you feel really comfortable with everything we've covered here, that's great. That means you're in good shape and you're ready to practice those practice questions. If there's particular questions you find that you're having a little bit of struggle on, well, that's okay, but that means now you've identified them and you've got a better idea about where you need to put your efforts and if you might need to ask for a little bit of extra help by sending me a message about one of those topics. Okay, now we've got some stuff to work on. That's also going to be posted, so let's work hard, let's work smart, let's get to it.